Reflection, refraction and diffraction. Reflection and refraction. First we'll look at a ray of light reflecting off a plane mirror. We call the ray coming in the incident ray and the ray leaving the reflected ray. To show the angles, we place a line at 90 degrees to the plane mirror, which we call the normal. This angle here we then call the angle of incidence, I, and this is the angle of reflection. Whatever the angle of incidence, we find that the angle of reflection is the same. So, angle of incidence always equals angle of reflection, or in symbols, I equals R. This is known as the law of reflection. Now to look at refraction. A ray of light is approaching a block of glass at an angle. As it enters the glass, it bends, as shown in the diagram. This is refraction. If we mark on a normal at 90 degrees to the glass-air interface here, we will call this angle I1 and this angle I2. Refraction is caused by a change of speed. The ray of light actually travels much slower in glass than it does in air. It's easier to understand how this effect comes about if we consider the much simpler case of a wheelchair travelling on concrete approaching a patch of grass at an angle. As this wheel hits the grass first, it will slow down, causing the wheelchair to turn. When the first wheel hits the concrete at this side, it will speed up, causing the wheelchair to turn in the other direction. This is the effect we would see. The wheelchair turns as it meets the grass, travels more slowly over the grass, turns again as it meets the concrete and travels more quickly. The wheelchair has been refracted. This shows what actually happens when light travels from air to glass. Some gets reflected, some gets refracted and passes through. This is how we can both see through a window and see our reflection in it. This shows us our reflection, and this is our ability to see through the glass. This diagram shows us what happens when a wave meets a gap. We have a straight wave arriving from the left, and it meets a gap of a similar size to the wavelength of the wave. As the wave passes through, it spreads like this. This effect is called diffraction. If we send the same wave through a bigger gap, in this case the gap is bigger than the wavelength, we get less spreading. The wider the gap relative to the wavelength, the less the wave spreads. Sound waves diffract as they pass through a doorway, which is why you can easily hear people talking in another room. We don't tend to see diffraction of light in everyday life, because light has a very small wavelength and so would only show significant spreading if it passed through a very small gap. Water waves, sound waves, light waves and all members of the electromagnetic spectrum can be reflected, refracted and diffracted given the right circumstances.